Okay, so we have a company that states that they have these cans of, I don't know, let's say soda, that holds 20 ounces. Well, quality control comes by and says, no, we think you're putting more than 20 ounces in these cans, and we want to check that. So what they end up doing is they take a sample, and we've sampled 42 cans, and found a sample mean of 20.04. So given a population standard deviation, we want to know, is that really probability-wise way more than 20 ounces? So what you typically do is you draw your normal distribution. This definitely can use a normal because we have a sample size greater than 30. And what they're stating is that my mean here is at 20. And what we want to know is the sample mean, which is over here somewhere, is this probability, this area right here, pretty high, saying that yes, it looks like we're putting more than 20 ounces of soda in these cans. So how you find this probability is by finding the z-value. The z-value is found by taking the sample mean minus the population mean divided by the population standard deviation, and in this case we have a sample size. So we do the square root of our sample size. So we just plug in our values, which is 20.04 minus 20 over my population standard deviation, and then divided by the square root of 42. So from here we get a value of 2.38. This is the value if we are standardizing. So what happens when we standardize the normal distribution? Standardization makes the mean 0, and this says how many standard deviations we are above the mean, because it's positive, so it's above the mean. So what does this, besides being the number of standard deviations, I want to know what this probability is that I would get a sample of a can that has 20.04 ounces or more. So we go to the normal table and we look up this value, and when you look up the value, this is giving me the probability, in this case, that my z-value is actually less than or equal to this value, because that's how you read the table, is it's given me up into that point, which is okay. I can get this value, which is 0.9913. So that's this probability. Well, I want to know this probability, this area. Well, that's easy enough to find, because all I have to do to find this now is take 1 minus that value. And why are we using 1? Because this entire probabilities have to add to 1. And we get 0.0087. So that would be our probability. What this means is if we want to compare this to, let's say we have some boss comes and says, well, all I care is that our significance is 0.05. Well, as you can see, this is a pretty small probability, which implies the majority of the time you're going to get 20.04 ounces or below. So we reject this claim and we say, yeah, pretty much your population of your cans of soda are going to hold 20 ounces.